An independent editorial defense analysis focused on Australia's strategic environment.
The arrival of the first MC-55A Peregrine at RAAF Base Edinburgh marks a shift. It is a subtle yet profound change in the architectural logic of Australian air power. This move goes beyond the traditional metrics of speed and payload. Instead, it pivots toward the dominance of the electromagnetic spectrum. While the visual profile suggests a standard Gulfstream G550 business jet, its introduction signifies the operational maturity of a networked warfare doctrine, a doctrine that has been in development for nearly a decade. This acquisition, under Project AIR-555 Phase 1, represents more than a fleet modernization effort. It signals a fundamental recognition. In a contested Indo-Pacific environment, the ability to maneuver undetected is predicated entirely on one factor: the ability to map, categorize, and suppress the electronic signature of an adversary. The strategic rationale behind the Peregrine rests on the necessity of high-altitude intelligence, surveillance, reconnaissance, and electronic warfare. By utilizing a civilian airframe capable of operating at 51,000 feet, the Royal Australian Air Force secures a critical line-of-sight advantage. The physics of electronic warfare dictate that altitude equals horizon. The ability to look down into the complex littoral environments of the northern approaches allows for the collection of signal intelligence without entering the lethal envelope of surface-to-air missile systems. This standoff capability suggests a doctrinal shift, a move from reactive defense to proactive environmental shaping. However, the integration of such a specialized platform introduces significant structural complexities. The decision to procure only 4 airframes creates an immediate bottleneck in operational availability. When accounting for the standard rotation cycle involving maintenance, training, and transit, the force effectively possesses a single deployable asset at any given time. This lack of depth highlights a critical fragility in the force structure. While the Peregrine acts as a force multiplier for the F-35A, Lightning II, and the Hobart-class destroyers, its scarcity implies that high-fidelity electronic support will be a rationed commodity. Consequently, the operational tempo will likely be dictated by the availability of the aircraft rather than the aircraft being available to meet every demand. This numerical constraint underscores a heavy reliance on Allied interoperability. The seamless integration of the MC-55A into the broader U.S.-led electronic warfare architecture suggests that Australia is positioning itself as a niche contributor. The data collected feeds into the Five Eyes intelligence network. Conversely, the effectiveness of the aircraft depends on threat libraries that are largely maintained by the United States. This interdependence raises a question regarding sovereign capability. While the hardware is Australian-owned, the software and the threat analysis algorithms usually remain under strict export controls. This potentially limits the ability to rapidly modify the system in response to a novel, localized threat. From a logistics perspective, the introduction of the Gulfstream airframe adds another layer of complexity to an already diverse fleet. Unlike the P-8A Poseidon, which shares a supply chain with the ubiquitous Boeing 737, the G550 is a unique type within the inventory. The distinct supply chain required for just 4 aircraft drives up the cost per flight hour. It complicates the logistics footprint, particularly when deploying to forward operating bases where commonality is preferred. It represents a procurement philosophy that prioritizes specific mission outcomes over fleet homogenization. The integration of the Peregrine also exerts pressure on the human element. The volume of data generated by modern sensors is exponential. It requires a back-end processing capability that far exceeds the demands of previous generations. The effectiveness of the MC55A is therefore not determined solely by the sensors on the wing. It is determined by the speed at which analysts can process raw signal data into actionable intelligence. This creates a requirement for a highly specialized workforce, a demographic that is currently in short supply. The bottleneck, therefore, may shift from the airframe to the analysis center. Furthermore, the operational concept must be viewed in relation to the denial capabilities of potential adversaries. As anti-access bubbles expand in the region, the permissive airspace that the G550 platform was designed for is shrinking. Unlike the F-35A, the MC-55A is not stealth. Its survival depends on distance and the protection of other assets. This tactical reality limits the independent utility of the aircraft in high-intensity conflict scenarios. The financial dimension also reflects a pivot in defense spending priorities. With a total program cost estimated in the vicinity of 2.5 billion Australian dollars, the investment per airframe is substantial. This valuation reflects the extreme cost of high-sensitivity electronics. It demonstrates that in modern warfare, the cost of the sensor often exceeds the cost of the platform. The government's willingness to sustain such high unit costs indicates a prioritization of information superiority over mass. Ultimately, the MC55A Peregrine acts as the central node in a kill web. Its ability to cross-queue with the E-7A wedgetail and the Jindalee operational radar network creates a multi-layered surveillance architecture. However, the reliance on a centralized high-value airborne node presents a single point of failure. If the Peregrine is neutralized or forced to withdraw, the fidelity of the electronic picture degrades significantly. This vulnerability suggests that while the MC55A is a critical step forward, it is likely a transitional capability on the road to a more distributed, unmanned architecture. In the final assessment, the MC55A Peregrine represents a high-stakes investment in knowledge-based warfare. It offers the Australian Defence Force an unprecedented ability to peer into the electronic fog of the region. Yet this capability comes with distinct trade-offs in terms of fleet resilience, sovereign autonomy, and logistical burden. The operational utility of the Peregrine will be defined by the capacity to manage these systemic risks, ensuring that this sophisticated electronic eye remains open even as the contest for the spectrum intensifies.